Today I'm going to review the rules or the test for independence. So in class we kind of highlighted this part of our notes, and over the past couple of days we have been talking about doing the test for independence. And I suggested that you should know both ways. So you should know how to do it either by using a given statement or by using the and statement. And we'll talk about different types of problems when you could use different options. So sometimes you can choose which one, and as we've seen by the Regents questions in class, sometimes the Regents is very specific about which of the rules for independence they would like you to use. Okay, so let's do a couple of examples to kind of solidify this understanding that we've already spent a decent portion of time talking about. So this is page 10 in your probability packet, and we'll go ahead and start with the example number 2. A survey was taken to examine the relationship between hair color and eye color. The chart below shows the proportion of people surveyed. If a person was picked at random, find the following conditional probabilities. Okay, and remember, conditional probabilities, that means a given or a such that. Okay, so what's the probability the person picked had brown eyes given that they had blonde hair? And so in probability notation, that looks like this. Brown eyes given such that they have blonde hair. So we're going to focus on the blonde hair column, right? So that's our denominator total. And we said in class that the 0.35 or the blonde hair, whatever's after that, given that or such that line becomes the denominator. So now in only this column, how many of those people chosen have brown eyes? So we'll find where the brown eyes are in this section, and that'll be 0.10. Now, I would prefer that you do not leave your answer like this, because technically you have a fraction within a fraction, which is an inappropriate or unsimplified answer. Okay, so we'll go ahead and reduce, and that would be 2 out of 7. Okay, so I'm going to ask you to go ahead and try part B on your own, okay? And then we will come back and talk about the answer, so take a moment to do that. Case of B, we are focusing on the green eyes row this time. So we're only worried about the green eyes. So that's our denominator, the total, 0.25. Out of those green-eyed people, how many of them have red hair? Okay, so we'll look for that red hair in that area. So 0.15, which we can simplify to 3/5. Okay, so now let's use that information to help us deal with the problem on the bottom. Does having red hair seem to have some dependence on having green eyes? You can check for independence using any of the formulas that we already discussed, okay? So since they already used in example B the probability of red hair given green eyes, we might as well use that as one of our proof options. So what's the probability of having red hair given that you have green eyes? Okay, and is that equal to, so we're going to question, is that equal to the probability of having red hair? If they're equal, then we have independence. If they are not equal, then we do not have independence. Now, we already found the answer, the value for red hair given that we're in green eyes, so we can put that answer from part B. So now we just have to check, what's the probability of having red hair? Okay, so we're going to go back up to our chart. And what's the probability of having red hair? So we're going to look for the red hair total. Okay. And so that's 0.20, which is essentially 0.20 out of 1, or 20 out of 100. Okay. And so we can reduce that, right? And so if we reduce that, 20 goes into itself one time, it goes into 100 5 times. So then the question is, does 3/5 equal 1/5? And since they are not equal, then the events of having green hair, having red hair and having green eyes have some sort of relationship. So they are not independent. In class, remember we said be cautious about saying dependence. It's better to say not independent, although some examples will express or use the word dependence. So if things are not independent, there's some story to tell, right? If they are independent, there's not really any story to tell. The charts would be essentially the same. So in this case, it looks like there's some sort of relationship between red hair and green eyes. If there wasn't, then the probability of red hair given green eyes would be the same as the probability of red hair, meaning that we wouldn't have this condition or a lessened value or total. Okay, I'm going to challenge you to try to also show dependence or independence using the other rule. So the probability of red hair and green eyes is that the probability of red hair times the probability of green eyes.